Hi everybody. Today we're going to be talking about the Python arcade game Asteroid Smasher. This will be the game that you will be creating AI agents to play for the final competition. Next slide. So before we get into all the information about the game and the code and everything, I do want to go back over some of the general info for the competition or for the challenge this year. A reminder, this is our website, the link here. We will be posting lots of information on there, more high level and general information, but still a good resource to have to check throughout the year. Uh, I also want to reiterate our Slack channel. If you go to this link, you can join our Slack channel. Brandon will give some more info about the specifics of the channels at the end of the presentation today. But this is the best place to get information quickly from both um, the organizers and also other teams. We encourage discussion between teams as well, so it's a really nice place to put thoughts down, get feedback, get help if you need it too. We also have the YouTube channel. All of our seminars will be recorded and uploaded to our YouTube channel so you can view them at any time. This is the link, including last week's kickoff, which is already uploaded. In case you missed that, you can view that too. Yep, so let's go ahead and get into the Asteroid Smasher code and repository. And Brandon is going to take over to show you how to set everything up and get familiar with the code. Brandon, are you able to take it from here?
Okay, yeah, sorry. My headset just died and I have to switch over. Good, now you guys can hear me, right?
Yep, sounds good.
Okay, cool. So, thank you, Tim. Let's just get started. We have been inspired by uh, the Asteroids game. I don't know what system it was from, but there has been a new Python video game environment that was created using the Python arcade library. They created a version of Asteroids that they call Asteroid Smasher. We have taken that source code and made our own environment that has a lot more features included that allows multi-agent play. We are housing this environment here. This is the GitHub repository where we do our development on the environment, and any time we make a new version, we'll make a release that will get published to PyPI. So when you need to use this in Python, you will simply just pip install fuzzy-asteroids or pip install upgrade fuzzy-asteroids. Um, so it should be really easy for you to get access to the environment and install it on your computer. We have another repo set up that we will show you later on that will give examples on how to use and interact with this environment. Um, but we'll just show you what this looks like in single player mode. This was from the environment last year where you can use your controller, your keyboard to um, shoot at the asteroids, you can move around, you can rotate. The turning radius is based on your speed. You have a limited shooting rate, and the asteroids have a stochastic behavior where when they're destroyed, they will randomly separate in terms of heading and speed. And you have a limited set of lives, and you also have a handy set of trackers below that can allow you to look at what your score is. Your score is simply just the number of asteroids you've destroyed, the current amount of active asteroids, the number of bullets you fired, and how accurate you've been. If you do hit multiple asteroids with one bullet, your accuracy could be greater than 100% because the hitboxes are what determine is a hit, and a hitbox may hit 2 asteroids at once. So don't be alarmed if you're seeing accuracy greater than 100. The The interface has been updated for multi-agent play, and it may look different from what you've seen here in the newer versions of the environment. So the way the game works is you have a score that's dictated by how many asteroids you hit, but when it gets to the actual competition, we may be considering other criteria when we evaluate the competitor's solutions. It will not just be asteroids destroyed. We may also include firing accuracy, how long you've been alive, how many deaths have occurred or crashes into each other or asteroids. How computationally efficient is your program? Will it scale to a larger number of asteroids, or will the system be bogged down and fall behind and you won't be able to put in control actions? And also system explainability and interpretability. This is more of an open-ended question that we are pitching to the competitors to see what they come up with, and if they can come up with any type of way of explaining how their system works in live real-time action, or any type of metrics to show why it's doing things throughout the whole process. We will leave that open for the competitors to figure out. The way it works is the system, which is your controller, will receive state information from the environment, and you will use the state information to modify the controls of individual ships. You can modify only a subset of the ship's actions, which include turning rate, throttle control, and shooting. You may have more than one ship. I don't think we've set an upper limit on the number of ships yet, but we will post that when we finalize that. You could expect any number of asteroids, so make sure that your solutions scale well. If it gets bogged down at 20 asteroids, then you might have a design problem. And you can do anything you want with this state data from the environment. You can develop your own asteroid density maps, use clustering. You can come up with your own algorithms for prioritizing which asteroid is more of a threat. So we've just given you a blank framework with which you can develop your own algorithms on top of and use fuzzy logic throughout. I will just pitch this to Tim and Javier, but I remember being asked in the past how much fuzzy logic is enough fuzzy logic for this competition, and we never really wanted to dictate that because we wanted to leave it open. But I'll just pitch it to you guys right now, see if you have any thoughts on how much fuzzy logic is enough.
Well, I would say first and foremost, the explainability is important. So fuzzy is, a great way to incorporate explainability into your AI solution, where other similar methods or other methods that you might be using in a similar way are not as explainable inherently. And there's not a clear-cut answer for how much fuzzy is enough fuzzy. Um, I would say it needs to be incorporated in your main AI solution, though.
Okay, thank you, Tim. So another open-ended question for you guys to help give us the answer to with your solution, but we do require the usage of fuzzy logic in your system, and we will leave that open to you to figure out how much is appropriate for the problem. So we've created this environment repository. It is posted on GitHub. You can get to it through this link. You can go through the source code. But the way it's worked out is we have it set up so it will upload to PyPI. You can pip install it on your computer. For this year's competition, we recommend using versions greater or equal to 2.0. And we will be making changes to the environment throughout the competition if we find bugs from the competitors, or if we decide to add new features to make it a more seamless operation. But when you need to, you can just use pip install or pip install upgrade fuzzy-asteroids. You can also use pip install -r requirements.txt. if you have more dependencies that you need to manage as well. So we also have another repository that's set up as your primary template for designing throughout this whole competition. It is held within this XFuzzy comp namespace on GitHub, and the repository is called fuzzy-asteroids example. This is a template that when you click on this use template green button, it will allow you to basically easily copy the repository code, store it on your own GitHub account, and then it's real easy to just get up and running, and then you can clone that to your computer and begin designing. So the link is on the slide. We will walk you through that process in a few minutes, and there are README instructions that are in the repository in case you need a resource after this video, or maybe you just want to follow a step-by-step instruction rather than doing it alongside this video. So when it comes time to developing your fuzzy controller, we've made a class interface that will provide everything that you need to be able to make a controller, provides the function signatures and the bare minimum methods that you need to instantiate and use the controller. The way it works is when you have your fuzzy-asteroids package, there's a fuzzy controller module with controller base and spaceship. Spaceship provides the definitions for methods when you're actually calling this list of objects, and then you have input data, which is the state environment data at each time step. So specifically when you're getting this in actions, it's that specific time step that you're trying to evaluate for. This is the current state data. You have this init function, which if you aren't familiar with Python, is it's called the constructor. You use it to create a fuzzy controller object, and once that object is created, then you can use it with actions, and actions will be called every single time step in the evaluation of this controller within the context of a scenario. And each time there is a new scenario, the environment will start fresh with the fuzzy controller, and then you'll have a clean slate to perform actions. We've designed this as a bare minimum interface, so you can apply your own design methodologies on top of this. You can use functional or object-oriented programming to design your controller, and we recommend not putting every single line of code inside of this actions function. We recommend breaking down your code into functional modules, classes, or functions that can simplify the control flow of your program and make it easier for your teammates to interact. There are a lot of great Python resources online that can just show you how to create functions and classes, and we just recommend, starting with some Python tutorials if you're not familiar with the syntax or how the language works. And then once you get going, if you run into any bugs or issues, we have the Slack where you can communicate with the admins as well as other teams to discuss theory and programming concepts. But we'll get into more detail in the Slack afterwards. We want to highlight that this is an open source competition, meaning our environment is open source. So you can go in and see how the environment is structured. You can even make contributions to it if you want to see a feature inside of the Asteroids environment. Open source has been a big part of software development for decades, since before I was born. So it's been really, really useful for people to collaborate on software, and it also helps promote trust, where you can see exactly how the software you're using is implemented, so you can understand that it's not doing anything bad to your computer. You can contribute and help make it more secure, and it can help with trust of software. It doesn't necessarily mean every open source package is safe, but at least you can go into the open source code and see what's going on. So we would also like to highlight, not only is the environment open source, but also the past competitor repositories are open source. The links to those repositories are in the appendix of this PowerPoint, which we will send out and also post to the Slack. We recommend that you keep your own repositories private until maybe a few days before the competition, when we have locked everything in, so nobody makes any more changes, because you don't want other people to accidentally collaborate with your great code that you guys write. And by this I mean cheating, but yeah, we want you to be safe and secure with how you have your code until it's time for the competition. Then all these solutions will become open source and everybody can see what happens after the winners have been declared. So that being said, we have a milestone that will be due after this. We will address that in a little bit. I think we will have Lynn talk about that, or Tim. I'm not quite sure who wants to talk about that, but we're just going to walk you through how to get ready for this milestone. And then we will talk about what we expect to see. Note that this is optional and it is just designed to help you guys get more acclimated to the environment sooner so you can make interesting solutions faster. So I'm going to step you through how we can set up this example repository and get started collaborating with my team or your team when it comes time to make your code. So I'm going to exit out of this. I'm going to go to GitHub. So note we do have this GitHub namespace that's called xfuzzy-comp. We have past competition in there where you can see how the old competitors operated on the competition environment. And then we have the two repositories that are continuously updated throughout each competition. So the fuzzy-asteroids is the environment that is published to PyPI. And then fuzzy-asteroids example is the repository that you will use to set up your own solution. So I'm clicking on fuzzy-asteroids example, and this is what this GitHub page looks like. We have made this as a template repository, so all you have to do to use this is to use this template, the green button. I'm going to create this repository under my own user account. I'll call this Brandon's Asteroid Controller. Brandon's example for this controller. So this is a description that just sets up a description on the main page for this repository. This is the actual link to the repository. So this is the name, namespace, and then before will be github.com. I'm making this public, and I'm going to create the repository. So now I have this. It's generating it from the template repository that we have, and it has all the code ready for me. And I want to collaborate with Tim and Javier, so I'm going to go in and give them access by going into Settings, Manage Access. I'm going to add Tim Arnett, Hollis, add him, and I'll also add Javier, Diana, AI. And then this is how you give your teammates access to be able to contribute without having to go through pull requests. Then with those GitHub accounts, they can simply just push to the repository. So it makes the development flow a little bit easier for your team to work. They can accept the invitations on their own end. They'll get an email invitation that will allow them to accept, and then they should be able to have instant access. So now that I have this repository, it's set up with the files and the template. I'll just walk you through what they are. We have this examples folder, which houses different ways of using the objects within the Python environment that we provide. So it just shows how to create a training script, how to create a scoring function, and how to create scenarios. We have scripts. These scripts are used for simple operations that you're going to be doing a lot. This might be running the game on its own with no controller. You may have to run the game with your designed controller. You may have to run training on your controller, and it just provides a very simple example of how you might do that. We've got this source folder, and this is where you're going to be housing your solutions. So the controller.py will be where you write your controller. You can add any number of files here that are imported into your controller or those other scripts. We've got scenarios where you can define your own scenarios for training or validation after training. We've got a score file where you can create your own scoring classes that allow you to try different types of weights and measures for judging how good your controller does over those scenarios. Then we've also got a test folder where you and your team optionally can write your own unit tests for making collaboration easier. So you can use it to check to see if any functions you made work correctly, and anytime anybody makes a change to their code, they can go in, run the tests, and see that they didn't break anything that you were intending to happen. But this will be optional, and the event coordinators may be adding in an integration test that we can use to verify that you haven't changed these repositories too much, where you won't be able to easily integrate into the competition repository, which we will develop later on in the competition. It may not be until 2022 when we make that. Then we have a git ignore, which tells Git what files it shouldn't consider pushing to your repositories or committing to your repositories. So in some cases, this might be a virtual environment or any binary files that you don't want even to consider pushing because it may cause conflicts for your teammates. You can read more about git ignores just by searching on Google or the Git documentation on why it's a good practice. We've provided an open source license, a README with instructions. This init.py is useful for creating modules in Python where you can't do imports without the init.py being in a specific folder. You can read more about how Python is structured in the Python documentation or on any number of Python guides online. And the requirements.txt is where you can add dependencies to make it easier for your teammates to share your environment. So if you need to change which fuzzy asteroids version you use, you can set it here, and then you can do pip install -r requirements to get that, or upgrade, and you can defer to this file as well. So that all being said, let's dive right down into just seeing what the environment looks like within the context of this repository. So I'm going to open my GitHub Git client. It's called GitHub Desktop. I'm going to add and clone this repository. I'm going to take this link. So you may see it here if, yeah, here we go. If you do refresh, you'll see the repository show up. And then it will auto give you a path that you can save to. So this will be where the code is stored. So now in PyCharm, I'm going to open this new folder up. So we will be using, so it's finally there. I'll try this again. Sometimes the program may struggle to update, so give me a sec. Oh, I saved it to the wrong one. I think it's there. Okay. All right, so I recommend creating a virtual environment, but I'll do this right now, actually. So virtual environments, they're very useful because it allows you to separate your dependencies into distinct environments where you don't cloud your global Python. So let's just say in this program, I use fuzzy-asteroids 2.0, but I still need to, in another repository, use fuzzy-asteroids 1.22 so I can look at last year's results. If I were to not use a global, or if I were to not use local virtual environments, I would be using a global environment, and I would need to change that dependency each time I use each library or each repository. So if I need to go change code in two different programs that use different versions, that can cause some issues. So I'll have to change that every time, or my code won't run. It'll just crash if I don't do that. So I recommend just using virtual environments. You can Google what are virtual environments and learn more about why it's an industry best practice. So I'm just going to create a virtual environment from this one. I see it wasn't made. Location directory empty. Sorry. Thought it was going to populate. Okay, now it should be good. You can see it right there. We have the git ignore set up, so your virtual environment will not be pushed or committed to your repository. So I'm going to add this existing virtual environment. And then you can either go into the terminal and PyCharm or just let PyCharm install the virtual environment for you. It may take a second for it to go and install the files, but if you were to do it manually, maybe you're not using PyCharm, you could also do this. And that should do the installation for you. But we'll wait for this to finally process the installed packages. It may take time because your integrated development environment is trying to map out everything that it thinks should be included in its internal monitoring system, and that allows you to bounce around your code faster or go dive into the dependencies if you need to look up how it's implemented. But I'll show you now. Let's see what it looks like when we run the game. So right here, I can use my keyboard to turn. I can go forward, I can go backwards, and I can also shoot like that. So we also have it set up so you can, and if you see this when you close the program, this is still something that's an issue with the Python Arcade library. You may get an error if you use a keyboard interrupt or you stop the program prematurely. So don't worry about that right now if you see that. But here we can actually now try adding a new scenario. I'm just going to take one from examples. Maybe I'll use this. So I will do from examples, example scenario, import scenario ships, scenario into run actually. And we will have two ships. I'll make it so one ship crashes into the asteroid. You can see the crash. You can have them shoot both at the same time. It is not currently implemented where you can operate these independently of each other in the bare bones basic game, but with your controller class, you can actually do that. So, for the time being, when you actually do your testing inside the environment by hand, you will just get this behavior where both of the ships, use the same controls. I'm going to run the game again just so you can see on the bottom right, there are these throttle and turn rate monitors. So when your program is running, you can see what turn rates are being reported. This is what's actually coming from your controller and being used by the environment, and this is what the current throttle and speeds are. Also has the number of lives and which ship is which. So ship number 2, ship number 1. And you can see only ship 1 is left, 4 lives, and I'll move on. So now right here we have the run game controller script. This will allow you to run the game with your designed controller. It is importing from source fuzzy controller, so it's going to be using this class. Now, for those of you not familiar with how PyCharm works, you can middle mouse click and it will take you to that class's definition. So I can go directly to where it's implemented. So it opens up that file, and now you can see this controller class, which looks similar to that one that I showed in the PowerPoint. This has some helpful documentation, so you can come back to it and see what it's supposed to do and what you have to work with. It has that init function, which is your constructor, which allows you to create an instance of this class. Then you also have this actions function. So this actions function gets a list of ships. They have this specific spaceship class that is your controller interface to the environment, and then you have your input data. This input data is a dictionary of a variety of values, which I'll print in the command line just to show you what it looks like. So if you run this file, it won't do anything on its own. It's not set up to have a run script. What it will do is it will just go parse this code and then be complete, and that's the end of the program if I were to run this file. But we want to actually see this work in the context of the game, so we would have to set up a script where we can use this fuzzy controller within the fuzzy-asteroid game. You can see how this is implemented again by right-clicking, and it will take you to the file that is saved in your virtual environment. And you can look through the source code if you're curious about how it's implemented. But we'll close that for the time being. We're just simply setting some basic settings, and we are using a specific multi-ship scenario, and we will run our controller over that. Now, what we're expecting when we run this controller is to see in the command prompt, we will be seeing the input data every time step, and the ship will, or each ship will be given a certain thrust value, which is the max of the thrust range, and we will be shooting as fast as we can. We will be trying to shoot every time step, but because there are rate limiters on the shooting, we won't be shooting every time step. I have a commented line out, which would control the turn rate, but this is not set because it's commented and it won't evaluate. So let's run this game controller script. And we are just going in a straight line, and we're shooting as fast as we can. The shooting rate's actually pretty healthy. Almost looks like a machine gun. But this is all of the input data that's available to you. We're seeing what frame or specific time step index we're on. This is an error, and we will need to make an update to that. That should be a floating point. We have whether or not a stopping condition has been met. We have map dimensions, every single asteroid state. And depending on the number of asteroids we have, this is a very long tuple. With each asteroid, we have what frequency it's running at, the position, velocity, how big the asteroid is. This is just a non-dimensional number that basically says at size 4, it can continuously break until it is size 1, at which point when it's shot, it disappears. So this can break 3 times and create child asteroids, and that's what the size means. And the angle is the direction that it's going in. Or actually, I think that that's the direction that it is pointing. So, but for an asteroid that is mostly just saying it's rotating, this isn't the rotation, derivative, but it is what angle it's pointing in. It matters more for your ship than it does for the asteroids, but it does semi-matter a little bit because these asteroids are not perfect circles. I think we still need to talk about what you have available within the context of this ship, but you can see we're still publishing this to your command line every single time step, and if we are not printing this out, you can see that we have these prints that, okay, this may take a second, yeah, so we get crashing messages. So it tells us which ship crashed at a specific asteroid at what time. So you can turn these on or off through the settings dictionary that is given to the environment. You can see in the examples that there are multiple settings that you can use. There are default values, but you can also go in and change whether or not certain things are on or off. So if I run this with prints off, you should see when we crash that we're not getting any prints. When you use the training environment, you will see no prints because you probably don't want to see a ton of prints if you're running 100,000 evaluations of the environment, so it'll just be a lot of nonsense. But I'll just clarify, there are 3 levels of environment. We have the asteroids game, the it's asteroid game, fuzzy asteroid game, and trainer environment. You can go into fuzzy asteroids and find these. So we've got, actually, I'll do this here, and then we'll just use the introspection to go see it. So we've got fuzzy asteroid game, and trainer environment. So the asteroid game is a child class that's used by fuzzy asteroid game and the trainer environment, and each of those simplifies the settings to make sure that certain criteria are met. Like if you are running the fuzzy controller, you don't want to be disrupted by keyboard events, so it will turn off keyboard events, and the trainer environment will turn off sounds, prints, and I think there's one other one I'm forgetting. Yeah, keyboard events. So there's a longer list here. I think there might even be a couple missing, but we'll make the code change and give you guys that information when we make the updates to this. So that's how you create a controller. You give a controller to the run command using a specific scenario. Each of these scripts and examples show you bare bones how to do things, and we may update with more examples later. Specify a controller using this signature. And now let's just try something. Now let's see what happens if we set the ship turning rate. So what we're doing is for each ship, we are going through and setting the turn rate, the thrust, and shooting. In your algorithm, you might want to do this in a smarter way, where each ship does something differently depending on its state relative to the environment. And you need to loop through the ships and assign actions based on how you want to intelligently run your program. But we're just giving you a naive example right now where we can just make these go in a circle, a very useless circle. So yeah, each one of these are running in a useless circle, and it's doing okay. But let's just say for the final competition, you want it to do more than that. One thing that I didn't fully address was that there are ship-to-ship collisions. So right here, I'll make a ship collapse, crash to each other, and they respawn at the same spot. So you'll need to make sure that with your limited invincibility time, that you vacate the center point of the environment so that you do not have a lot of crashes. Now, Tim, I want to hand this probably over to talk about the milestone or maybe additional questions. What are your thoughts? Should we address any questions first or after the milestones?
I think if there are any questions, yeah, let's go ahead and take any of those now. Oh, it looks like we're down to one active participant.
Okay.
Um, yeah, so let's go ahead and talk about the milestone. Um, the milestone it is optional. When we say that it is due, that just is more of a guideline for checking your own progress. But what we would like you to try to do is, well, first of all, make sure you can get the code and get it running correctly, based on what Brandon just did with the repository. Familiarize yourself with the structure of the code so you know what functions you need, where you can get the information you need, like the state information, like Brandon mentioned, to input that into your control system or to do other calculations with. And then also we want you to be able to actually modify the behavior of the agents, because right now they just take keyboard inputs like Brandon was doing, but we want you to, in the code, do something to modify their movement, modify their shooting, and then just modify some of the information from the input data that Brandon was showing, and use it to calculate something, whether that's it doesn't matter what it is. We just want you to get comfortable playing around with those numbers and where to access that information and make those changes. Brandon, would you like to go back to the code to
Yeah.
mention some of these
So
things?
basically what we'd be looking at is within the context of this template that we give you, going in to this controller file and changing the behavior of the ships in some way. So essentially we're giving you the classic hello world, where you just try to do some bare minimum changes to make it work, for something very simple. So, for example, one thing you could do is you could have each ship fly in a circle around a particular asteroid. And, that's fine. You can do that. Or you can have them fly in a zigzag pattern. We'll leave it up to you. This is optional, so you can have fun with it. The more you try to play around with the environment and understand what it's doing, the more beneficial it will be for you later on. So we're kind of leaving up to you to play around. But you would just have to go into this controller file, go into actions, and then do some fun math using maybe the math library, which is bad. I would recommend doing imports at the top, but maybe you need to use cosine. I'm assuming a lot of you guys know how trigonometry works, so you can understand how you might need these types of functions to do certain maneuvers. So you can use anything within the Python standard library for this. We recommend not going to any external libraries quite yet. Just makes it easy for you to get this going. But have fun with it, make it do some interesting things. It doesn't have to be a smart controller. We're trying to get you used to the environment before we start assigning you guys to start adding fuzzy logic into it. Yeah, when you need to run this, you just use this run game controller script. It should be importing your fuzzy controller. So any change you make in this file will get propagated to the behavior in this file. So this is how I would use it, these two files to make those changes.
Yeah, something else that you could do as a really quick but useful exercise is, it doesn't have to be smart, it doesn't have to be good or effective, but taking some action with your agent based on the information you're getting from the environment. So like right now, Brandon just had actions that were just happening. It would just make those things happen. Also, maybe try, taking in some of the information in input data and then basing some action off of that.
it may be useful as you guys are designing this to just add in a print statement so that you can debug what's going on, but I recommend getting used to the debugging. Surprised I didn't print. Oh yeah, I think I turned off prints, that's why. So here, maybe you get a printout of this input data within your controller. Oh, that's why I'm writing the wrong script. Yeah, right here, maybe it's easier for you guys to just take one of these, make a new file or save it, something like this, so then you can see how to access this dictionary. So you can look up, the asteroids, find the closest one, find a specific one, fly along the map boundaries, and you can use your ship state, which here I'll show you. When you use IDEs, you get some really interesting features where it will go in and understand what's going on in the environment for you. So you get really nice autocomplete. So right here, if I do dot or ship dot, it will give you a list of suggested things that you can do. So you can see like what is your X positions of the center point of your ship, what angle am I facing, what's my ID, am I respawning or not? This is not a Boolean, it's a floating point. I think when it counts down to 0, when it's 0, you are not respawning anymore and you're active. And when you're respawning, you're invincible. If you shoot early, you end your respawning prematurely, and you can take your ship data like this and process it however you want. You can also save that information off if you need access to it as well, or some quick resource. But yeah, you can do anything with the information that you have here. This is information about your ships, and you can control this, and then this is information that is read-only. So asteroids and stuff about the environment. Anything else, Tim?
Not at the moment. But when you go back to the slides, let's talk about Slack some more.
Okay, yeah, let's do that. So moving on from the milestone, just try to familiarize yourself with the structure of the code and how to control agents using those two files that I showed you. Then now we'll kick it back open for the Q&A just in case any questions were perked up. But about the Slack, we have sent invites out to, I think, most, if not all, of the Slack competitors. So, sorry, we sent out most of the information to the competitors to be able to access the Slack. You'll notice you have access to different channels. We've got the discussion channel, which is where we encourage discussion on programming concepts, syntax, maybe fuzzy logic or AI theory, and you can discuss between teams on this, and maybe admins or judges may contribute as well. But this is intended for you to communicate and discuss maybe common issues you're running into. Hey, has anybody ran into this error? And then, oh yeah, this is a Python error. Some person says you need to do this instead. So just allow you guys to discuss what's going on. I expect you probably won't give away any big details about your design and discussion. You tend to keep that in communication amongst your team. The general channel is where admins, so the event coordinators, will be able to post updates about milestones, deadlines, any updates related to the code, and you'll just be able to receive those notifications from general. Help is for help is for where you go when nobody is able to help you out with the discussion in the discussion channel, and you have some error that is related to the environment that you can't solve or you're having trouble with. There are some issues with the backend simulation environment that you may run into, and we can help you out when you get to that point. And we have another one that's just called off topic. I don't remember if the dash was there. I think it is. Yeah, the dash is there. So this is where you can just network with the teams and the admins, discuss things that are off topic, but keep it clean. We hope we don't have to moderate the chat too much on this, but have fun with each other. And we've got 4 event coordinators. I think everybody but me introduced themselves last time, but just to highlight this again, we have Javier, PhD candidate, University of Cincinnati. He's your point of contact for general competition info, scheduling. We have Lynn, who you can come to with questions about fuzzy logic toolboxes or maybe the code. I can also, my name is Brandon Kunkel. I can answer questions about the codes and the repositories. And then Tim, he will be who you come to about information related to the milestones, deliverables, and the seminars. And I guess that's it. We'll leave it open for any comments from Javier, Tim, or questions, comments, concerns from the, I guess we just have one participant right now, right? Yeah, we have just one. But
Yeah, so we can stay on for a few more minutes to answer any potential questions. Of course, as Brandon just mentioned quite a few times, I'm going to say it again. If you have more questions, Slack is probably the best place to do that and get a
yeah,
quick answer.
agreed, Tim. We will probably say we prefer answering questions in the Slack. If you were to email any one of us individually, maybe you email Lynn for a question about the code. Maybe she doesn't know the answer. I can step in if it's in the Slack, but it's harder if we do that via emails. Um, so let's prefer discussion questions in the Slack, and then we'll reserve the email for special cases.
All right. Well, if there aren't any questions, we'll go ahead and call that a wrap for today. This will be uploaded onto the YouTube channel before too long, definitely this week, so teams can review it as they need to. But